So we're going to take a look at the binomial theorem. Let's start by saying, well, what is it? So the binomial theorem is the expansion of x plus y to the n. Binomial meaning two, and I have two terms here, x plus y. And then we just want to talk about, well, how do we expand that? So let's take a look back at some things we should be familiar with. Let's start with x plus y to the 0. That's just 1, right? Anything to the 0 is 1. If I look at x plus y to the first power, well, I'm not doing anything there, so it's just x plus y. Starts to get interesting when I look at x plus y squared, and we remember when I square a binomial, we should get a trinomial. So here I have x squared plus 2xy plus y squared. Start to stretch our memory a little when we go over to x plus y cubed, and that would be x cubed plus 3x squared y plus 3xy squared plus y cubed. And don't freak out right now if you don't remember that. That's okay. I'm going to step you through, well, how would we come up with it again if we needed it? Beyond just going x plus y times x plus y times x plus y. So I want to take a little bit closer look, and you can see what I did is I took the coefficients on the right on the expansion and I put them in red. So I want you to see the first row is 1, then I have 1, 1, then I have 1, 2, 1, and then I have 1, 3, 3, 1. So what I want to do is kind of make the rest of that disappear. So take the x's and y's away and just pull out those coefficients and put them over on the right. And look at how I laid them out into a triangle. And as much as I would love to take credit and say, look how smart I am, not what's going on here. This is something called Pascal's triangle. And that's what I want to look at. So look at this pattern, and I drew arrows in to try to help you out. That if you see here when we start with this 1, well, I pushed it down 1 and 1. But then as we continue to go down into this pattern, I pushed the 1 over. Then I did 1 plus 1 is 2. And then I moved this 1 over. So again, I repeat this. I put the 1 down. 1 and 2 makes 3. And then 2 and 1 makes 3. And then this 1 came down. So I have this combination of the previous rows give me the next row. So I showed you over here, if I continued, I would have the 1. 1 and 3 would be 4. 3 and 3 would be 6. 3 and 1 is 4, and that 1 comes down. And what happens is these are the coefficients of the expansion for the binomial theorem. So I just showed you a bunch of rows, and you can just see like where we're at. This is to the 0. This is 1, 2, 3, 4, 5, 6, 7, 8. So kind of the second term really tells me what power was I doing when I do my expansion. So let's use Pascal's triangle, and let's find the expansion of x plus y to the 6th. And let me just kind of highlight this for you so you can see which one we're using. I'm using this row right here. So here's our coefficients, 1, 6, 15, 20, 15, 6, and 1. Right. I also want you to look that when we're starting this, we're going to start with x raised to the 6th, y to the 0. X is going to go down, so I'm going to have x to the 6th, x to the 5th, x to the 4th, 3, 2, 1, 0, and then y is going to do the opposite. It'll start at 0, and it'll slowly increase, 1, 2, 3, 4, 5, and 6. So here's what I have. I'm starting, the first coefficient is 1, and x is to the power 6. Then I pick up the 6, x drops a power to 5, and y picks 1 up. I go to the next one, 15. Again, x is going to drop 1, y is going to go up 1. Go over to 20. X went down, y went up. 15, I just continue that pattern. X went down, y went up. 6, x went down, y went up. And then at the last one, it's just y to the 6. I want you to notice here that these exponents always add up to the power that I'm doing for the binomial theorem. So I was doing 6, this is 6, 5, and this is a 1, that makes 6. 4 and 2 is 6, 3 and 3 is 6, 2 and 4 is 6, 1 and 5 is 6. So there's easy little checks built in there all along for us to make sure we're doing this correctly. Another way to find the coefficients of the terms, if you don't want to have to draw out that Pascal's triangle, is to use something called a combination. So a combination of n choose r is the number of ways to select r of n objects without replacement, and it's really important that n is greater than or equal to r. So this is something we use in statistics and probability. It comes up over and over again when we're doing mathematics, but this is where it falls in for us right now into the binomial theorem. And because of how it's going to be put into the equation, we use a different notation. So here, this n over r in parentheses kind of looks like a fraction. It is not supposed to have a line in between it. This is important. This is the notation we want to use when we're doing the binomial theorem and expansion to find our coefficients. What it's equal to mathematically is n factorial over r factorial times n minus r factorial. Kind of big. All right, so let's just take a look at factorials. N factorial means I'm starting with n, and n is going to be a natural number. It could be a whole number too, that would be okay. And we just keep multiplying it by the numbers less than it, so we keep counting down. So if I had 6 factorial, it would be 6 times 5 times 4 times 3 times 2 times 1. So we're going down by whole numbers. You can multiply that in your calculator and get 720. This is commonly used, so it shouldn't surprise you that you have this on your calculator, so you look for an exclamation point. It could be an exclamation, it could be X exclamation, it could just be an exclamation. If you're looking on your calculator and you just can't find it, look for a PRB button, and sometimes it's hidden in that menu. Just to note, 0 factorial is 1. This is by definition. Don't try to figure out why does that work. It's just needed for this to be a complete kind of topic for us. So anytime I have 0 factorial, it will be 1. You should also have a button on your calculator for combinations. It probably won't look like that notation I just showed you. It'll probably look like CNR or NCR, and it should be close to wherever you found that factorial button. Just to check it out and make sure it works right, try to calculate 5, choose 2 in your calculator. If you need to, pause me, take the time and find these buttons so you can check it out. You should get 10. And just as a second check to make sure we're getting it right, I'm going to give you a second number, and I'm showing you again, here's our notation. So my notation will be 5, 2, but you'll have to hit a different button. I want you to try 7, choose 3. And you should get 35. Okay, so I'm just showing you again side by side Pascal's triangle, but then this change of look that on the right side it was just the numbers, coefficients, and on the left side it's using that notation for combinations if you wanted to see both of them. Okay, so here's the binomial theorem in a different way. All right, so this is x plus y to the n is the summation from k equals 0 to n. So this says we're going to start at 0 and we'll stop at n of n choose k. So it's a combination of x to the n minus k and y to the k. And then again, the repetition of here's what that n choose k makes. Don't get hung up on that. It's not that bad. All right, so let's take an example that I've expanded for you of x plus y to the 4th. So you can see, and it might be good to do this in parts. I started with 4, choose 0, then I have 4, choose 1, 2, 3, and 4. So I'm starting at 0, stopping at 4. Powers for x start at 4 and drop 3, 2, 1, and 0. Powers of y start at 0, 1, 2, 3, and 4. So there's a lot of patterns you can follow here. 4 choose 0 is 1, so that goes away. I just have x to the 4th, y to the 0 is also 1. So all of this turns into this. 4 choose 1 is 4. I have x cubed y. 4 choose 2 is 6. I would have x squared y squared. 4 choose 3 is 4. I have xy cubed. And then 4 choose 4 is 1. This is 1, so I just have y to the 4th. Again, mess with your calculator. Make sure you understand how to plug these in so that you can do it quickly. We're not expecting you to do longhand combinations all the time. I want to show you bigger, so I dropped the power down to 3, but I increased what the binomial is, and I made it 2x minus 5y. Really important that you attach that negative to the 5, so as I'm doing the expansion, the signs will change. Again, I'm starting with my power 3. I go 3, 0, 3, 1, 3, 2, 3, 3. The x term, or the first term, goes 3, 2, 1, 0, and the second term goes 0, 1, 2, 3. So I'm putting in some steps. 3 choose 0 is 1, I dropped it. 2 cubed is 8, x cubed I keep, this is 1, I'm going to drop it. 3 choose 1 is 3, 2x squared gives me 4x squared, and this is negative 5y, so you can see I put those in. 3 choose 2 is just 3, 2x to the 1 is 2x, the negative 5y squared is 25y squared. And then the last term, 3 choose 3 is 1, 2x to the 0 is 1, negative 5y cubed is negative 125y cubed. To make this look better, I just kind of multiplied out. So 8x cubed I kept the same. 3 times 4 times negative 5 is negative 60x squared y. 3 times 2 times 25 gave me 150xy squared. And then the negative 125y cubed stayed the same. So I thought it'd be good if I had you try one. So I want you to try 3x plus 4y to the 5th. Ignore what I wrote on there, kind of pause this for a minute. Try to work this out, see if you're getting it, because that's always so important, is for you to be able to do it yourself. And then when you're ready, come back and check your work against mine. All right, so again, choosing 5, I go 0, 1, 2, 3, 4, and 5. So it's always counting up when I'm doing my combinations. And then for my first term, it goes 5, 4, 3, 2, 1, and then 0. And the second term starts at 0 and it goes 1, 2, 3, 4, and 5. I don't have the difference in signs this time, so it's just really straightforward. So the 5 choose 0 is 1. 3 to the 5th is 243. I have x to the 5th, and the 4y is 1 because it was raised to the 0. 5 choose 1 was 5. 3x raised to the power 4th gave me 81x to the 4th, and then 4y. 5 choose 2 is 10. When I cube 3x, I get 27x cubed. 4y squared is 6y squared. 5 choose 3 was 10. I squared 3x, and I got 9x squared, and then the 4y became 64y cubed. 5 choose 4 is just 5. 3x stays as 3x. 4y to the 4th gave me 256y to the 4th. And then 5 choose 5 is 1, 3x to the 0 is 1, and 4y to the 5th was 1024y to the 5th. So I put terms together where I could, so I kept the 243x to the 5th. 5 times 81 times 4 gave me 1620 x to the 4th y. 10 times 27 times 16 gave me 4320 x cubed y squared. 10 times 9 times 64 was 5760 x squared y cubed. 5 times 3 times 256 was my 3840 xy to the 4th, and then I kept my 1024 y to the 5th. That's it.